All right, let's jump right in. Today we're going to talk about how artificial intelligence is no longer just some tech buzzword. It's becoming an absolutely critical tool in the incredibly high-stakes, super expensive game of making computer chips.
You know, I love this quote from Emerson because it perfectly captures the whole spirit of the semiconductor industry, right? It's always been about blazing new trails and doing the impossible.
Well, that's where we are right now. The trail they're blazing is now so small, so incredibly complex, that it's pushing the absolute limits of physics. And when a single mistake can cost you millions of dollars, well, the stakes have never been higher. To really understand what's going on, we first have to talk about the massive problems chip makers are facing. Think of it like they've run up against a gigantic billion-dollar wall of complexity. And I'm not kidding about the billion-dollar part. Just let this number sink in for a second. $20 billion. That's the price tag to build just one of these advanced chip factories, what they call a fab. When you're spending that kind of money, there's literally zero room for error.
So, what's the problem? Well, for one, we're smashing into the laws of physics. The components on these chips are now so small, they're measured in angstroms. Silicon itself is getting so thin, it's starting to fail. Even the amazing tech we use to print these circuits, EUV lithography, is struggling to produce enough perfect chips. We are at the physical limit of our current materials and methods.
And here's what that looks like on the factory floor. The old way of checking for mistakes, it's just not working anymore. Imagine this, up to 40% of the error warnings are false alarms. It's an incredible waste of time and money, with engineers chasing problems that don't even exist. Okay, so you have these massive, expensive problems. What's the solution? Well, manufacturers are turning to a whole new playbook, and the star player is artificial intelligence. This isn't just a small tweak, it's a fundamental change in how they operate. And this chart right here shows you the before and after. It's a total game changer. We're moving away from being reactive, waiting for something to break and then scrambling to figure out why. Now, with AI, it's all about being proactive. It can predict a failure before it happens, turning a tidal wave of useless data into a handful of insights you can actually act on.
And listen, this isn't just some far-off theory. This is happening right now. Industry leaders like David Parker saying it flat out. AI is cutting down on those false alarms and helping engineers find the real problems way, way faster.
One of the coolest tools in this new playbook is something called a digital twin. Okay, so think of it like a perfect virtual copy of the entire multi-billion-dollar factory. It's like a flight simulator, but for chip manufacturing. Engineers can try out crazy ideas and push the limits in the simulation without any risk of breaking the real thing.
And here's a look at how companies are putting this stuff to work right now in 2025. Samsung is using AI to link the chip's design directly to the manufacturing process. Others are using AI to combine data from a bunch of different inspection tools to get one complete picture of any defects. It's all about using AI to connect the dots and stop problems before they even start.
So, as you can imagine, this new AI playbook has kicked off an absolutely fierce global competition. In this high-stakes race, the company that masters AI in its factories first could build a lead that no one else can catch. And this chart? Wow, it really tells the story. As of late 2024, TSMC has an iron grip on the market, with almost two-thirds of it. This puts incredible pressure on competitors like Samsung and a resurgent Intel. For them, AI isn't just a nice-to-have, it's their main strategy for trying to close that gap. And just look at how fast this race is moving. Every single one of these new process nodes, like N2 or 18A, is a massive leap forward, making chips smaller and more powerful. TSMC is even introducing a game changer with backside power to make chips more efficient. Look, being first to one of these new nodes can lock up billions in contracts, and AI is becoming the key to hitting these insane deadlines. But here's a huge development. Intel has managed to land Microsoft as a major customer for its next-gen 18A process. This is a massive deal. It's basically a vote of confidence in Intel's new AI-driven roadmap, and it seriously heats up the competition with TSMC and Samsung. So, where does this all go from here? Let's peek into the near future, at the AI-powered factory of 2026 and beyond. What's that going to look like? Well, the future is all about teamwork, but for machines. You can't just rely on one tool anymore. Instead, you'll have this seamless workflow. One machine scans for problems, another zooms in, a third looks for hidden defects, and then a central AI brain pulls it all together to pinpoint the exact root cause. It's brilliant. And the ultimate dream here is to link all of those digital twins together.
Imagine a seamless data flow from the moment a chip is designed to the moment it's packaged. A small change in the design could automatically adjust the machines on the factory floor weeks later. The whole process, orchestrated by AI.
And this is where it gets really mind-bending. AI is graduating from just optimizing the factory. As researchers at IBM point out, AI agents, like the large language models we hear about, are now starting to actively help design the next generation of chips.
And that really brings us to the big question, doesn't it? This isn't just about making things a little bit better or a little bit faster. When AI starts designing and building the very hardware that makes it more powerful, you have to wonder if we're at the very beginning of a brand new industrial revolution.